In this lesson, we briefly learn about some of the more important corona maps. The first important map is corona ambient occlusion. Let's open up Node Material Editor, create a new corona material, and assign it to this toy truck model. Add a new ambient occlusion map and connect it to the diffuse color input of the corona material and run the interactive rendering. Ambient occlusion allows you to approximately fake or simulate global illumination or indirect diffuse lighting. Back in the time when using global illumination was very expensive and would take forever to render, artists would use ambient occlusion to simulate global illumination without having to use the full solution. Also, you can use ambient occlusion to add a bit more detail to your render by multiplying the ambient occlusion pass over the beauty render, or to add dirt, for example, to the corners and nooks and crannies in your render, which is probably the main usage of ambient occlusion, can be this kind of last one. Occluded and unoccluded colors determine the color of the occluded and unoccluded areas. Let's change the occluded color to red and unoccluded color to blue. Max distance is the maximum occlusion distance that is sampled. So if I set it to something like 1, 3, 5, or 10 centimeters, we start to get ambient occlusion in the broader areas. So you can use lower values here in case you are interested in the very fine details. For now, let's set it to something like 3 centimeters. Color spread controls how focused or diffused ambient occlusion should be. So as I increase it, I am basically compressing the effect and increasing the contrast between occluded and unoccluded areas. At 100%, we only have two distinguished colors, red and blue, and there would be no gradation between occluded and unoccluded colors. Let's set it back to 0% for now. Max samples controls the quality of the ambient occlusion. The higher the max samples, the cleaner the render and the slower it would be. Then we have this calculate from, which determines where the occlusion is sampled: outside, inside, and outside plus inside. The inside option is like enabling the invert normal option in ambient occlusion map from V-Ray or Arnold. Now let's change the calculate from to outside for now. Also, let's set the color spread to 100, occluded color back to black, and unoccluded color to white. This is a simple procedural black and white map, and you can think of it as any other black and white map. For example, if I connect this map to the reflection color input of my corona material, the black parts are gonna make the material to not reflect at all, and the white parts make it completely reflective. So let's disconnect the ambient occlusion for now. In the material, disable diffuse and enable reflections. Now set the Fresnel IR to 999. Probably we can decrease the glossiness a bit as well. And now connect the ambient occlusion map to the reflection color input. And as expected, the ambient occlusion map controls the reflection, and where the map is black in the corners we get 0 reflections, And obviously where it's white, we get a fully reflective surface. And the next important map is the Corona Color Correct, and we have used it numerous times throughout the course, so you should be quite familiar with. Then we have this Corona Color Mix map, which we have used it as well in the previous lessons. It basically allows you to mix between a solid color and a texture using Photoshop-like blending modes. We talked about Corona Normal, Ray Switch, and Tone Map. We also used the Corona Triplanar on a few occasions previously, but due to its importance, let's briefly take a look at it as well. For now, let's hide the truck and unhide the sculpture model. Assign a new Corona material to the model and load a Corona Triplanar texture. Triplanar map allows you to quickly map a texture without using a UV map by projecting it from all the 6 sides. Let's load this woodparquet.png and connect it to the diffuse color. You can see the model doesn't have any UVs and it's a total mess. Now let's connect the bitmap to the Corona Triplanar X input. And because in the triplanar the use map X for all axes is enabled, the same map will be used for the Y and Z projections as well. And now connect the triplanar to the diffuse color input. And voila, the map is nicely sitting on our model without having to do any UV mapping. And the triplanar does that by projecting the map onto the geometry from all the axes and directions. In the triplanar itself, you can define separate maps for all the axes. If I disconnect the texture from the triplanar and disable this use map X for all axes, now we are basically projecting these red, green, and blue colors from different sides. We have this blend amount which allows for blending the projections from different sides. If I set it to something like 0, 0.2, or even 0.5, we start to blend the colors or define textures. And down here you have some basic offsetting, rotating, and scaling options to control how the map will be exactly projected. So if I connect the texture again and enable use X for all axes, now I can increase the scale to something like 200 centimeters. And get a much bigger map projected onto the geometry. Or I can rotate it on X for like 50 degrees. So you have all of these controls. The next important map is UVW randomizer. For this, let's hide the sculpture and unhide these planks. Create a new Corona material and assign it to them. Load the same wood parquet texture and connect it to the diffuse color input. Also select the texture tag and decrease its styling to 0.2 and 0.2. In the interactive renderer, you notice because these boxes have the exact same UV, the wood texture has been applied the same way to all of them, and this is exactly what UVW randomizer fixes. UVW randomizer map allows applying random offset, rotation, scale to textures and procedural maps assigned to different objects. So let's add a UVW randomizer and connect the wood texture as the input and connect the UVW randomizer to the diffuse color. Now you can simply use the U and V offset and scales to randomize the UVs on those objects. First, we need to change the randomization mode to instance in this case, and change the U offset from negative 200, let's say, to 200, and V offset from negative 100 to 100. And now we have completely randomized the texture pattern on these three objects, and they look much more realistic. You can play with the rest of these parameters on your own. Let me stop the render for now. I'm going to hide these planks and unhide the truck. In the material editor, create a new Corona material and assign it to the truck. And the next map here is this Corona wire. Let's load it and connect it to the diffuse color. And run the interactive render. As you can see, it renders a wireframe version of the geometry, and here you can change the base color, the color of the edges, the thickness, and some other rudimentary options. Now let's stop the render and hide the truck and unhide this geometry called cube extruded and assign a new Corona material to it. Finally, we have this round edges map. So let's load one, and we need to connect this to the bump map input of the Corona material. Let's set the radius to about 2 centimeters. What round edges does is to make the sharp edges rounder, and it has a few simple parameters. If we need any additional bump mapping on our geometry, simply we can connect it to this additional bump mapping, for example, a noise or something like that, and that would do the job. And obviously, using this radius parameter, you can control the amount of roundness that you want. So that's about Corona maps, and we conclude this section about Corona materials and maps. See you in the next section about cameras.